Alright guys, so this video is 2.5. It's on compound inequalities, and this is where inequalities get a little bit tougher. And one of the first things that really makes it difficult is understanding how to put these types of words into sentences. So we have a number x that's greater than negative 8. So I guess what I could do is I could just start by writing x is greater than negative 8. Right? But also we want to realize that it's less than or equal to 4. So this number x is also less than or equal to 4. So I'll write x is less than or equal to 4. Now I have a red inequality and I have a blue inequality. And I want to take the red and the blue inequalities and put them together, right, to make a purple inequality. Let me try to move my x is less than or equal to 4 over here. X is less than or equal to 4. So red and blue together make purple. So how would I write this inequality all as one thing? I like to call it a sandwich. What's the lowest thing out of all of those? Is it the x? Is it the negative 8? Or is it the 4? Which is the lowest of all those things? Yes?
Negative 8.
Negative 8, because negative 8 is in fact less than x, right? Let me not put a line there. So if negative 8 is the smallest, I'm going to write it all the way on the left, and I'm going to show that it's less than x. And now, because I'm already there, why don't I just take this guy right here and kind of like copy paste it in here? What would you finish this off with? What would you finish this off with? Exactly, thank you. So less than or equal to 4. So this is how we write a compound inequality. It's just going to be what's in the box. If it's okay with you, now that you've seen this, I'm going to go ahead and erase the red and the blue, because the only thing that's the answer is not the red and the blue, it's just the purple. Remember, you can pause and rewind the video if I'm going too fast, or if you wanted to remember what those red and blue things were. But that's the answer. So now we look at this next one and we say a number y is at most 0. So y is, would that be less than or equal to, greater than 0, greater than or equal to, or just straight up less than? Nice work. Is at most 0 is less than or equal to 0. Whoops. Or it's at least 2. So that means y is greater than or equal to 2. Now when we have an or, we're literally done. All we have to do is write the word or in there, because you can't make a sandwich out of that. So here's the first big idea, okay? Are you ready? This is the first big idea. I'm going to use a highlighter here to show you. When you have an and, you're going to make this sandwichy looking thing, okay? It's going to combine into one inequality. When you have an or, you're going to literally use the word or and write the inequality separate. Does that make sense? Yeah. That's really all there is to it as far as that is concerned. So just to clarify that one more time as we've done these, whenever you see an or when you're writing an inequality, you write it as two separate inequalities. And every time you see an and, you have to do extra work to make it into that purple and yellow sandwich there. All right, so one of our subs had come in with a question here, and they said, how do you flip the inequality symbol around? And I think actually, let's see. The deal is this. We look at the purple, okay? So just look at the two purple, like rainbow there, okay? If you have x is greater than negative 8, the x is being eaten by the Pac-Man. You can also say x is greater than negative 8 is the same as saying negative 8 is less than x. So you can switch these two guys around, the x and the negative 8, this guy and this guy, you can switch them, but you also need to switch the symbol. So basically you switch everything. So if you say, like, I'm taller than Joe, you're also saying Joe's shorter than me, right? It's the same idea, agree? Sorry, Joe. Does that make sense? So it's the same idea as saying I'm taller than Joe and Joe's shorter than me. It's the same thing, right? So that's what the flipping is doing. Make sense? Cool. All right. So now what we're going to do is, and I know we're jumping around here a little bit, is we're going to solve the inequality. Now this is a little bit weird, but it's almost like a three-sided equation or a three-sided inequality. These, would you guys have represented these with an and or an or, by the way? Just reviewing the last thing we said. Yeah, these are all ands. So if you know they're ands, you might even know what they look like. You might not at this point. But when you do an and, right, on a number line, it's always going to look something like this, right? It's going to look like a dumbbell, a barbell, I like to say. So we'll graph that in a second, but for right now, let's just work on them. So here's the deal. Look at the variable, and what needs to go? What needs to get out of there? Yes? The negative 2. So we need to think about this as adding 2 here, yes? If we've added 2 to the left side, what do we need to do to the right side? Right, so we got to add 2 here. But have we added 2 everywhere? No, we also need to add 2 here. It's like a 3-sided equation. It's almost like, you know how I have that scale in my classroom, the pan balance? It's almost as if that pan balance had 3 balances and there was 1 pivot point in the middle. Does that make sense? It's weird, but it can work. So now we have the following. We have negative 2 is less than x is less than 5, and we're done. And now what we can do is graph that. What's the smallest number that's going to show up on our graph? Yes? Negative 2. So let's just go ahead and put negative 3, negative 2 like this maybe. Negative 3, negative 2. Open or closed? Open, I believe, right? Because of this. This is open. And then we're going to go all the way until 5. So negative 1, 0, 1, 2, 3, 4, 5. Open because of this, not having a line. And because it's an and, it's going to look like a barbell. Okay? It's going to look like a barbell. So what I want you to do is pause the video and try B. I want to remind you of a rule. If you happen to, on B, divide by a negative, what do you have to do to the inequality symbol? Exactly. You must flip the inequality symbol. So pause the video and try B. Okay. So you paused the video and you tried the problem, and you might have found a couple of hiccups on this problem, if we want to call it that. It gets a little bit tricky. There's actually a lot of things. First, you're doing 2 steps. You have to get rid of the 1, you got to get rid of the negative 2, then you got to flip the inequalities. Then your answer doesn't really seem right because the small number's on the right and the big number's on the left, and it's awkward. So let's try to go through B and see where it becomes an issue. So I think we all know what to do first, right? What do we do first? Subtract 1, minus 1, either way. So we're going to minus 1. If we want, we can have that. We got negative 4 is less than negative 2x is less than or equal to 8. And we're in pretty good shape now. We still have one more step, though. And I think most people know that, yes. Divide it by negative 2. And do you want to add anything to that, Aiden, when I divide by negative 2? Yeah. Make sure you flip the inequality signs at that time. If you're dividing everything by negative 2, you have to flip all of the inequality signs. And this is your answer. This is actually an acceptable answer, but it's not a preferred way of writing it because I feel like it's weird to have the small number on the right and the big number on the left. Don't you? So what I would do is I would rewrite this equation. Even though it's a little bit of work, I think it's going to be the smart thing to do. So what I'm going to do is I'm going to put the negative 4 over here. Now, is the negative 4 being gobbled up by Mr. Pac-Man? No. So he shouldn't be gobbled up this time either. Now, is the 2 being gobbled up by Mr. Pac-Man? Yes. So he should be in this situation. This is what you want to work with. So now let's talk about the number line. Well, we know it's going to look similar to the one that we had over there, right? So where do we want to start? We want to be at 4, open or closed. Closed at 4, negative 4, sorry. We want to go this way-ish. And then we want to be at 2, right? And we want to be open at 2, and we want to go this way. Well, what you notice is that if you carry this red out, actually it still could go this way, right? And if you carry this blue out, I just want to show you something kind of cool. Where does red and blue happen? We want to know where purple happens. Where does purple happen? In between, just where it's both of those things. This is really your answer. Your answer is the purple. You don't need to do that red and blue thing. You can just go straight to the answer, right? But I'm just trying to show you how wherever they overlap, wherever it's both of those things, it's greater than a number and it's less than a number, that's what's going to be your answer. So really your answer is the purple part, and the red and the blue just kind of help you get there. You don't have to take the extra step, but I figured why not show you one time, right? So that's how you do those types of problems. So we're in pretty good shape right now. All right, peeps, we're moving right along. We're going to do an OR. Now, an OR is going to look a whole lot like an OR, okay? An OR is going to look like an OR. Not an OR. Oh, that's OAR. It's not going to look like an OR. It's going to look like an OR. This is just not a very good OR. Oh, okay, cool. So OAR. So let's look at this one, and basically it's pretty simple. You just kind of deal with it all separately. So like you don't do anything different. You just solve this guy, and then you solve that guy. So solve the guy on the left. It shouldn't be that big a deal. What do you got to do? Yes.
Matt,
Yes, exactly.
Please call the high school main office.
That will be on our video. Okay. So we have this, and then what do we do? Yes, divide by 3, right? And what does it come out to? Yeah, exactly. Now I'm going to put the word OR here, and I'm going to solve the other one. That's all I'm going to do, separately solve both of them. Now how about this one? How do we want to solve that one? Jump right in. Shout them out if you know them. Add 1, yes? After we add 1, we have 2y is greater than 6. What's the next step? Divide by 2. Y is greater than 3. Okay, an OR is going to look like oars on a boat. You see what I'm saying? So here's what I want you to see. The number line goes, and we have -1, and we have +3, 2, 1, 0, I guess. Okay? We want to be at -1, and we want to be open at -1, and we want to be going less or greater. Do we want to be going less or greater? 11? Okay, so to clarify, I just cleaned up a couple of things over here because I sometimes have sloppy handwriting, and as you can see, that's a +1 to both sides of that inequality and canceling out. Okay, so anyways, we're back to our simple graphing. Do we want to go less or greater on the green one? Less or greater? Y is less, so we want to go this way. It kind of looks like the oar on a boat, like a cruise ship, right? A cruise ship, not a cruise ship. Okay, now we got the blue one, and that's going to be at 3. Is that going to be open or closed? That's going to be open at 3. Are we going to go greater or are we going to go less? Greater. So this is how we graph an OR. Does that make sense? That's how we graph an OR. So really, we've kind of summed it all up. We've done a little bit of everything. The only thing I'd want you to do is one more, which maybe I'll just keep it easy on you, and you pause the video and try this problem here. If you're feeling ambitious, try number 4, okay? You don't have to try both. Try number 3. If you're feeling ambitious, try 3 and 4. Pause the video and give that a shot. When you are done, you are done. So I will see you soon.